Let's have a look at the key parts of an index expression. Now the whole expression is called a power. So if you've got something raised to the power of something else, you call that entire thing a power. And the power is made up of two parts. It has the base part and then the small number that's written up here, which you call the index or the index number or the exponent. All those things mean the same thing. Now when you see the word indices, indices is just the plural of the word index. So if I have an expression like a to the power of b times n to the power of n, you might say that b and n are the indices and a and m are the bases. Let's have a look at the index laws now, and we'll look at an example of each one so that we can see why these laws exist. Now with the first one, we're multiplying two powers and the bases are the same, but the indices are different. And the rule is that if we're multiplying and the bases are the same, then we add the indices. And if you forget this, you can always do a quick example to remind yourself why it works. Let's say we have anything. We can put a number here, or we can actually just put a letter. We could put, say, 2 to the power of 3 and multiply it by 2 to the power of 4. If we expand this one out, we get 2 times 2 times 2. There are 3 of them there. And if we expand this one out, we're multiplying by this one, which is 2 times 2 times 2 times 2. In the end, we can count up and see that we've got 7 of those 2's there. So we know that this is the same as 2 to the power of 7. So of course the quick way is just to add the 3 and the 4 to get 7. The next rule is really similar, except opposite. If we're dividing powers and the bases are the same, then we subtract the indices. Now note that it can be written this way or this way. They're the exact same thing. And looking at an example to check why it works, again we could use a base that's a number here, like a 2, or we could use a letter, doesn't matter what it is. Let's go a letter this time, just to prove that it works. We'll use a's. Now if we had something like a to the power of 7 divided by a to the power of 3, then what we've got on the top is we've got 7 of these multiplied by each other, 5, 6, 7, and on the bottom we've got 3 of them. So it makes sense that if we divide by a, top and bottom, and then do it again, and then do it again, each time we've divided by a, we're replacing those with a 1, aren't we? So what we've really got is a to the power of 4 on the top and 1 on the bottom. So that's basically just a to the power of 4. And the quick way we can see is to just do 7 minus 3 to get 4. Now the next one, raising a power to another power. When we do this, we need to multiply the powers. Here's an example to show why. Let's say we'll use 2 again as our base. If we had 2 to the power of, say, 3, and we wanted to raise it all to the power of, let's say, 3, then if we just take the part inside the brackets, the 2 cubed, and cube it, that means we've got to write it out 3 times with multiplication signs between each one, and those expressions are now the same, aren't they? We've cubed the 2 cubed. We can then expand further and say, but 2 cubed, that's 2 times 2 times 2, and this one is also 2 times 2 times 2, and so is this one. So what we've got there, in fact, 1, 2, 3, 4, is 9 of these. So our answer is 2 to the power of 9, and of course the quick way is to say we could have done 3 lots of 3. It makes sense too if you think of it that we're going to do 3 plus 3 plus 3. We're basically applying this rule, aren't we? And here we could say it's 2 to the power of 3 plus 3 plus 3. So you could either expand it out to see that it works, or you could just, if you already understand this rule, see that it's actually the same rule. Now the next one, anything to the power of 0 equals 1. To understand this, we need to think of 2 facts and then bring them together. So in our example, we can take any base and any index number, it doesn't matter what it is. Let's say we've got 5 to the power of, 7. We could pick any number here and any number there. If we divide that by itself, then we know 2 things. First thing we know is that anything divided by itself is 1. And the reason we know that is that's just not an index law, that's just basic maths. To divide something by itself, you always get 1. So we're going to write that we also know something else, but 5 to the power of 7 over the 5 to the power of 7, we can use this law to say if we're dividing and the bases are the same, we need to subtract the index numbers. So we get 5 to the power of 7 minus 7, don't we? And that's the same thing as 5 to the power of 0. So if this expression that we came up with equals 1, but it also equals 5 to the power of 0, then we know that 5 to the power of 0 must have been 1. Now we can do this example with anything. It wouldn't matter what we used as the base and what number we used as the exponent or index number, because you're always going to get itself minus itself. You're always going to get 0, aren't you? And you're also going to get 1. Now where we need to be careful with this rule is when you get something like, if I ask you what's 4x all to the power of 0, that whole thing to the power of 0 is 1. But just be careful, because if you had something like this, the only thing that's been raised to the power of 0 there is the x. So it's 1, and we've got 4 ones, which is 4. So you've got to make sure you really think there about what it is that's been raised to the power of 0. Now these next two are pretty much the same. What we're saying is, if we're multiplying or dividing two numbers and then raising them to a power, it's the same as raising them to that power separately. Now I can prove this is true really easily. Let's take a number like, let's do 2 times 3, and we'll raise it all to the power of, let's say, 3. Now what we've got there is we've got 2 times 3 times 2 times 3 times 2 times 3. I've just taken my 2 times 3 and I've cubed it, which means I've written it out 3 times with time signs in between each. But then, of course, you can always rearrange and do 2 times 2 times 2, which is 2 cubed, and multiply that by 3 times 3 times 3, just by doing them in a different order. And you can see that if they're multiplied together and raised to a power, that's the same as raising each of them to that power separately and then multiplying them. Now be really careful here, this only works when they've been multiplied. If you've got an expression with a plus or a minus in there, it doesn't work with this rule, so be very careful. Same thing will happen when you're dividing. And here, instead of using 2's and 3's, let's use the A's and B's just to show you it doesn't make any difference. If we had something like A over B all to the power of, say, 3, then what that means is we've got A over B times A over B times A over B. And of course, the way we do that, the numerator times the numerator times the numerator, on the top we've got A times A times A. And on the bottom we've got B times B times B. So we've got A cubed over B cubed. So we can see that the rule makes sense and that it's always going to work.